Hello, I'm Dave Brown, and today we're going to talk about mechanical couplings. First of all, what is a coupling, and what's its purpose? The basic idea behind the coupling is to connect two shafts, and throughout industry there are a number of reasons for doing this. As indicated here, we have a motor that is driving a reducer. In order to do this, we must have a means of connecting the two, and we accomplish this connection with a coupling. The first question that comes to mind is, okay, why not weld the shafts together? Theoretically, this might work, except for a problem or two. For instance, what would you do if you wanted to take the two apart? One of the first couplings devised was what is known as a sleeve-type coupling. A sleeve-type coupling is nothing more than a piece of rod that has a hole drilled in it, and we cut a keyway running the full length of the inside. There's also a set screw on each end. To connect two shafts, we place the first shaft in one end, the second shaft in the other end, and we might say that this effectively welds them together. Another coupling, which is essentially the same but is used so that the shafts don't have to be taken out of place when the coupling is removed, is called a split sleeve coupling, and it's split down the middle so that we may bolt the two sides together. Now, this particular type coupling, in fact, is still frequently used on overhead cranes where we have long shaft lines that are relatively limber. The next coupling along this line is the flange coupling. In this case, we have a flange which we slip on the end of each shaft, then we bolt the two flanges solidly together. This may be done with two shafts which are the same size as we see here, or with two different size shafts by simply boring each coupling half out to fit its corresponding shaft. Now, either the sleeve or the flange coupling works well and will do a perfectly adequate job where the shafts are completely aligned or where the distance between supports is such that the shafts themselves serve as flexible members. The problem is that rarely are the shafts completely aligned. This only happens in the case, well, as a matter of fact, it only happens by accident. A mechanic has good intentions of lining them up, but he's rarely able to get this done exactly. So he tries to get them as nearly aligned as possible, then he uses some type of flexible coupling to absorb the rest. There are several types of misalignment. First, there's the case where the shafts are not aligned parallel. One is either higher or lower than the other. Next, we have angular misalignment, or where the two shafts intersect but are not parallel. Now we have a combination of these two. The shafts do not intersect and are not parallel. Finally, a situation where we have end movement or end float. When conditions exist, as in the case we've just covered, some type of coupling is necessary which will take care of the difference in alignment. This coupling must be some type of flexible coupling, and on the market there are hundreds of different styles and methods to obtain this flexibility. I'll cover a few of the most common types today. The first, and I suppose the most commonly used coupling throughout industry, is the chain coupling. Here we take two sprockets, put them together, and wrap a piece of double chain around them. And we have a coupling. The chain coupling has a certain amount of flexibility and will tolerate about 1/2 of 1 degree angular misalignment. It is a relatively rugged and economical coupling, and depending on whose brand you use, most are made with standard double roller chain and with standard configuration on the teeth of the sprocket halves, except that the tops of the teeth have been cut off, as you can see here, instead of being left pointed, as you see here. Also, the teeth on these units have been hardened, as compared with these off-the-shelf roller chain sprockets, which are not normally hardened. Now, in an emergency condition, this sprocket, a standard stock sprocket of comparable size, will fit and work right in, and you can use one standard stock and one coupling half. The difference is that the teeth, as you see, protrude a little bit further on the stock sprocket, and the teeth are not hardened. Remember, in an emergency condition, the coupling can be composed of a piece of regular roller chain and 2 stock sprockets. This would make a perfectly effective chain coupling, as you see right here. Now these come in all sizes, this one being a larger size. Again, on the larger sizes, we can still use a stock sprocket to make a coupling. These coupling halves also come with taper lock ends. Or you could use, in an emergency situation, a standard QD or taper lock sprocket. This happens to be a QD with a taper hub, so it's not necessary to bore the sprocket, as you can get the hub which will fit directly on the shaft. The hub has already been pre-bored, and the taper allows it to clamp up, as we discussed in our roller chain tape. These couplings are normally installed with a sheet metal cover, like this, or with plastic covers similar to this. These covers help keep the dirt out as well as the lubricant in. And as for lubricant, roller chain couplings are usually lubricated with relatively heavy grease. Now let's look at a similar type of chain coupling using standard stock sprockets. These sprockets may be either taper lock or QD, or, as in this case, a standard stock bore. We take a piece of special Delrin chain, as you see here, and we wrap it around the sprockets. This allows us to have a coupling such as this, and it has several advantages. It requires no lubrication. It has 1 degree allowable misalignment, and it's made up of standard stock sprockets. Also, as you can see, since it is smooth on the outside, it doesn't require a cover. And finally, any pin can be knocked out to disconnect or reconnect the chain. Now, what if we wanted to carry more horsepower? We'd simply get a sprocket with more teeth and wrap a correspondingly longer piece of chain around it. This particular coupling is especially convenient since the only item that should be stocked as an extra would be a piece of Delrin chain, since it works with normally stocked size 40 roller chain sprockets. The next type of coupling is still a type of chain coupling. In this case, we take 2 silent chain sprockets with hardened teeth, and we wrap a piece of silent chain around them. Now there's a holding link, or guide link as it's sometimes called, which goes in the groove on one half, and the other half has no groove. This allows for a linear movement. This half is held, and this half can move, thus allowing movement in and out. Some of the features of this type coupling: it'll take about 1/2 of 1 degree misalignment. It's a heavy-duty type and will take more shock loading than the normal chain type coupling. It will carry more horsepower at slower speeds. It will allow for in-play or linear movement of up to 3/4 of an inch, depending on the coupling size. Although these couplings are frequently installed without a cover, the use of a cover and grease lubrications will extend the life of the coupling some 2 or 3 times. Again, the cover may be plastic, or as you see here, metal. You'll notice the grease fitting, which is used for lubricating the unit. Now next we have gear couplings. Gear couplings are produced by several different manufacturers, and in fact there are some 25 or 30 manufacturers of this particular type unit. In this case we have 2 gears. A gear is put on each of the 2 shafts which are to be connected. Then over each end we slip a cover which has internal teeth that mesh with the teeth of the gears. You See that right here. Now this particular unit allows 1 degree misalignment. And we've now ended up with a coupling which is bolted together and has an outside cover. There we go. Bolted together and an outside cover. Fitted bolts are used to assure proper alignment. Some manufacturers use tongue and groove on the halves to achieve this alignment. At this point, I should stop and explain mounting the gear part of the coupling onto the shaft. Most couplings are bored out with a clearance of 1 or 2 thousandths and installed with a square key to keep the shaft from rotating in the coupling. In other words, we make the hole slightly larger than the shaft, and this works perfectly well in most applications. However, in heavy shock conditions or with reversing loads, there is a slight movement between the coupling and the shaft. After a while, this causes wear. Finally, of course, it would cause failure. To prevent this, some coupling manufacturers recommend interference fits. This is where we actually make the hole in the coupling smaller than the shaft it's going on. Although a shrink fit is used, a key is still necessary. The assembly is accomplished by making use of one of the properties of steel called thermal expansion. As steel is heated, it expands. So if we have a cylinder of steel and heat it, the hole gets larger. Now, since the metal expansion is minute, in the order of 7 millionths per degree, we must heat the coupling half to 350 degrees to 400 degrees. And care must be taken not to overheat it, since the heat treatment may be affected. One of the best ways to accomplish this heating is in a bucket of oil. Once the coupling is installed and cools off, it tightly grips the shaft since the hole is smaller than that shaft. This then is an interference or shrink fit. This interference is normally 5/10,000ths per inch of shaft diameter. That is 1/2 of a thousandth per inch. This particular coupling is extremely heavy duty and will do a fine job under severe shock loading. It also works equally well at high speeds or with low speeds, high torque applications. For extremely high speeds, normally specially balanced units are required. This coupling is available for extra large sizes. For example, this unit can be had to couple 2 30-inch diameter shafts together. To get more misalignment capability, we can curve the teeth, as indicated here. This allows us 3 degrees angular misalignment for the same basic type coupling, the other components being the same. This coupling is especially adaptable to a condition which requires large end play or axial motion, since all that's necessary is to make one side of the internal gear as long as the required movement and extend the hub on the gear half. These, of course, are special. The gear type coupling is also adaptable when making a torque limiting device. This is done by putting shear pins between the halves, and when a predetermined torque is exceeded, the coupling parts, allowing the unit to run free. There are other configurations which make up this type of coupling. For example, instead of bolting together the parts with the integral gear, at least one manufacturer uses a sleeve instead. As you can see here, we have 2 gears. This particular one has curved teeth and allows 3 degrees misalignment. It has a sleeve which has teeth cut internally, and the sleeve slips over and connects the 2 halves. Now they're held together with a spring clip which goes into the end groove here to seal the unit in place. In addition to the couplings I've shown you, there are those with various types of flexible center members. A very basic coupling, which is frequently used on very small horsepowers, utilizes a piece of rubber hose. Here we put a clamp on each shaft with a piece of rubber hose in between, and this serves as a coupling. There are various methods of doing this very same thing. In fact, there's one type manufactured which has a rubber center member that is bonded to two metal pieces on the end. This, in effect, a piece of rubber hose. There are a number of different methods of having a flexible center member. Here's one style which has 4 rubber biscuits in the center held by a metal ring. These two are connected on one side. These two are connected on the other side, and this serves as a flexible unit. This may have as much as 2 or 3 degrees misalignment. These particular couplings come in larger sizes, and in the larger sizes, the biscuits are compressed and the metal insert made in them so that all the motion is in the rubber. We connect 2 to one side, shown here, 2 to the opposite side, and this gives us up to 5 degrees flexibility. All of the movement is taking place in the rubber. This particular coupling has nothing to lubricate and no seals to break down. Another method that is similar to the one I showed a moment ago and uses a flexible center disc, a rubber member is inserted here between 2 halves, causing this to serve as a flexible connector. These are also made in larger sizes, as you see with this unit, this being the rubber disc, which is inserted in the center section. A larger unit in a little different style has a centerpiece which is connected all in one, and these are wrapped around to make up the completed flexible coupling. There are a number of other styles of flexible couplings. For example, here's one which is referred to as the rubber tire coupling, and in essence is a rubber tire. This shaft is connected to one side of the rubber tire. The other shaft is connected to the other half of the rubber tire, and the flexing takes place in the tire itself. Here's another unit which has a flexible center disc similar to the one shown a moment ago, except here the ring is continuous. In this style we have notches cut in the center member, and these notches are plugged into each end of the coupling. Something you don't see much of anymore, but at one time was fairly common, is a rope-type coupling. And since you rarely see it, we aren't going to show it to you. Also, there's a metal disc coupling. This particular coupling has one distinct advantage in that it has no backlash. Backlash is the lost motion or slack that is in the unit when we reverse directions. We take a series of discs, as you see, and clamp one side to one end of the coupling. We clamp the opposite side to the other end of the coupling. In order to get more flexibility, the unit is normally composed of 2 series of discs here and here, which gives added flexibility to the total package. Here's a similar style which also has relatively little backlash. This is the leaf design coupling. One end is connected here, the other end connected here, and the two connected together in the center, which gives us flexibility. There is, in addition, what is known as a steel grid coupling. This is where we have a hub on each end, and we connect these with a flexible, continuous steel grid. Now, as these two rock around the center grid member, it gives us a flexibility. The cover goes on like this, and this gives us a complete coupling. Today I've covered most of the common couplings, but actually There are hundreds of additional coupling styles with different ways to do a specific job and different designs for specific applications. This concludes the Tel-A-Train tape on couplings.